revise and do some exam type questions on geometry. So here's our first one. Okay, have a look, and I'm going to leave you for about 3 minutes, see if you're able to solve this one on your own. If you have any questions, you can raise your hand. Our class is nice and small this evening, so you can ask lots of questions. Don't be shy. Okay, 1 more minute. Right. Who's got an answer for X? Pop it in the chat. Let's see what you got. Pop your answer for X in the chat. Who's got an answer for X, guys? Pop it in the chat if you know already what X is. Moheen says X is 10. Thanks, Moheen. Who's next? Let's see your answers, guys. Monete also says x is 10. Okay, Mohino Monete, do you want to tell us how you did it? Do you want to raise your hand, unmute, and tell us how you did it? Great. Hi, Mohin. You can unmute.
First question tells us that ABCD is a rhombus.
Yes.
So what I did is opposite sides are parallel. So that means that 2x plus 10 degrees is equal to C2 because of alternate interior angle.
Nice.
And then the properties of a rhombus, the diagonals bisect 90 degrees.
Yep.
So I said 3x plus 30 degrees plus 90 and plus 2x plus 10 equals to 180 because angles of a triangle.
Yep.
And then I added it all up, and then at the end I got 10, x is equal to 10.
Lovely, great, well done, Mohin. That's exactly right. Okay, so using the properties of a rhombus, we can say that angle C2 is equal to 2x plus 10, and that's because of alt angles. AB parallel to DC. And then, yeah, I was a bit quick with this here, because we have to give all our reasons. It's 5 marks, so there's a fair amount of stuff you need to write down. So then we can say angle DEC is 90 degrees because the diagonals of a rhombus, you can just write it like that, diagonals of a rhombus, and then you can make your equation with the 90 degrees and the 3x plus 30 and the 2x plus 10 is equal to 180, angle sum of triangle, and you're going to solve your equation. You're going to get 5x is equal to 50. That's just taking the numbers over to the other side and then dividing x by 5, x is 10. Okay, good stuff. All right, so we're off to a good start. Let's see, let's do some proving of parallelograms, which you can definitely expect in your paper too. So what have we got? In this diagram, KLMN is a parallelogram with KO perpendicular to LN and MP perpendicular to LN as well. So first question asks that we prove that KNO, triangle KNO, is congruent to triangle MLP. Oh, let's just go back. The 50 degrees comes from going 180 minus 90 minus 30 minus 10 to get the x by itself. That's where the 50 comes from. Okay, back to this question. Let's have a look. How are we going to prove that triangle KNO is congruent to MLP? So we do know that this is a parallelogram. So the opposite sides are parallel. They're also equal. And let's put our parallel line arrows on. Okay. So that's that. And let's see if we can prove that KNO is congruent to MLP. I'm going to give you about 2 minutes to have a look at that and see how you can do it. If you have your answer, raise your hand. Tell us how you did it. Also a good idea to maybe make a quick sketch in your book or your page, there where you are, and to work from that sketch, because it's very difficult to work off the sort of screen when you are doing geometry. We are proving these two triangles congruent. Anyone ready yet? Where will we start? So far we've got a side and a side. So Kn equal to Lm. That's because of the opposite sides of a parallelogram. And then we've got KON 90 degrees equal to LPM. That's also given. So we already have a side and an angle. What else can we get? N1 is equal to L2 alternate angles. Good stuff, yes. I'm going to make a little dot there. Because Kn is parallel to LP. Well done, Siamo. That's right. Is that, or Lm, that's fine. So do we have enough now for congruency? Come, everyone should know this. Can we say yet that these triangles are congruent? And if they are congruent, what is the case of congruency? Put it in the chat. Yeah, side angle, angle. That's right, Siamu. Well done. I don't know where everyone else is. Come, guys. Remember what we say about participation. It is the most important thing in mathematics is to try, okay, and to participate, especially as we go along and we actually find these things and it gets easier and easier. Right, so we're going to start in triangle KNO and triangle MLP. First thing we're going to say is that Kn is equal to Lm, and that's opposite sides of a palm. And then we're going to say that KON is equal to LPM, and the reason for that is given. We are provided with that. And then question the third statement we're going to make is N1 equal to L2, and that's because of alternate angles KN parallel to LM, opposite sides of a palm. Okay, so you can put both those things down, and therefore triangle KNO is congruent to triangle MLP, and that's because of angle, side. Okay, now for the next thing, we have to prove that KOMP is a parallelogram. Okay, so I'm going to take this away. And you can also, there where you are, draw in the parallelogram that you have to prove. KOMP. Bearing in mind that we've just proven that those two triangles are congruent. So what's nice about that is that all the sides are now this, all the parts of the triangle are actually the same, which means KO, I'm running out of stripes here, KO and PM are equal. And they are equal because of the congruency. And so the other thing, so we already have one pair of opposite sides equal. So can we make them parallel? Well, if you look at what was given is this angle here, KON. So that will also be 90 because of the straight line. And this one will be 90 because of the straight line. And then when you actually look at those two angles that we've just indicated as 90 degrees, they are alternate. And because they are alternate and they are equal, it actually means that KO is going to be parallel to PM. And that's going to give us our parallelogram because one pair of opposite sides is going to be parallel and equal. Okay, so let's put all of that down. Let's start by saying that PM is equal to KO. And the reason for that is that triangle KNO is congruent to triangle MLP. And then we can say angle angle KOP is equal to 90 degrees, angles on a straight line. And for this, with that same reasoning, MPO is equal to 90 degrees, also angles on a straight line. And then you can say, but KOP and MPO are alternate angles. Therefore, KO is parallel to PM. And that's because alternate angles are equal. And therefore, we can then say KOMP is a parallelogram because one pair of opposite sides parallel and equal. Okay, are there any questions about that? You can put it in the chat. Raise your hand if you have a question. If you're happy with that, put a thumbs up. Put a thumbs up in the chat. It's like crickets out there tonight.
Yeah, it's like dead silence.
Let us know you're alive, everybody. Only Anamika and Nyasha and Tiamu. There's Robin Lee also alive. And Buffalo is alive. Signs of life. Okay. Right, so that's proving. Let's see what else we can do here. Let's do this one. Okay. Some midpoint theorem, an exam question on midpoint theorem. Here we go. Okay. As always, I am going to leave you to it. And please, guys, be ready to answer and put stuff in the chat and to raise your hand and to participate. Like I said, this is a small class this evening, so we really can make the most of it. Okay, so we'll check back in about 3 minutes. Okay, right, our time is up. Put in the chat, what did you get for your first answer? The length of BM. Question 1.1. What did you get? Are you guys still busy? Okay, Emmanuel says DE is 12 because of midpoint theorem. Good stuff. Do you have a distance for BM, Emmanuel? Anyone else? Come, guys, let's get this going. Who's got the distance of BM? DE is 12. That's great. And just remember, we've got, if this is a midpoint, BC is equal to CE. That's what this means here. So C is a midpoint. And MC is parallel to DE. Then we can say that M is also a midpoint. So this side is going to be equal to that one. And because DE is parallel to MC, we can say, and P is a midpoint, that's given. It means that D is also a midpoint. So that's also going to be 3. So that should make it much easier now. What is the distance of BM? Come, some more answers. Yeah, so you always start with what is given. What was given is that we have a midpoint at C and we have a midpoint at D. And then from there on, it's pretty straightforward. Okay, so BM is 5 centimeters. Okay, now what is going to be the length of DP? Yeah, DP is 3 centimeters because now DP is going to be half of NC. So that's right. And then lastly, what will DE be? DE, I think someone gave it right at the start already. But put your answer there if you know what DE is equal to. Emmanuel said it was 12. Good. Okay. Here's our whole answer for it. I just did it with the other class as well. So if you want to take a quick screenshot of what the answer is, there we go. Also, we've been using in this course, we've been using line from midpoint, parallel second side. That's fine. You can also use converse midpoint theorem. Converse midpoint theorem is also acceptable. Okay, how do we get BM? So BM we get because C is a midpoint and MC is parallel to DE. And because MC is parallel to DE and that it's given that P is a midpoint, AP is equal to PM. That means D must be a midpoint. So AD is equal to DM is equal to BM. And AD was 5, so DM is 5, and MB is 5 because they're all midpoints, so they must all be this equal in length. Okay. Yes, so converse midpoint theorem is the same, and you can use either. I did confirm that with somebody. I asked about that, and you can use either. Because as I've said before, they're very strict with these reasons, so we had to make sure that you can actually use converse midpoint theorem as a reason. Okay. Right, let's look at a question where we actually have to combine the midpoint theorem and the proving parallelograms and all of that together. Okay, next question's up. It's probably going to be our last question for this evening, so give it your best. As always, I'm going to give you about 3 minutes to think about it and strategize. When you are ready to go over it and to look at what you've done, put your reading face in the chat. when you are done and you've worked out your answer, you've read through it, you know what is expected from the question, and you're ready to go through it. Have you got an answer, Emmanuel? That was very quick. Great stuff. Okay, let's see. Emmanuel, you say that BE is equal to GF. That's given. BE, GF. Be careful, that is not given. The only thing that's given is CE equal to DF. Okay, so this side and this side. Okay, but we do have all these parallel lines here. And okay, so now I've got some other ideas. BE is equal to BF. BE equal to BF. BE equal to BF. Given. Guys, these lines are parallel. They're not equal. Remember, arrows mean parallel, and stripes like this, markers on the sides, mean equal. Okay, the only thing that's given at the moment is that CE is equal to DF. So for those two triangles that we need to prove congruent, we've got a pair of equal sides, CE equal to DF. Okay, but we've got lots of parallel lines, which means we can find some angles that are equal. So this angle CBE, we can say it's equal to angle A. I don't know if that's useful. But we can also say this angle here is equal to this angle here. And that's also because of the parallel lines, BE parallel to AF because of corresponding angles. Yeah. Okay, and let's see if we can find, we've got a side and an angle. We either need another side or another angle. Let's see if we can find one. Yeah, we can. This one here, blue dot, is equal to this one here, also because of corresponding. C is equal to D, right. Nice, Boitumelo, that's right. Okay, I'm just going to take these away. And there's our congruency. We've got angle, angle, side. Okay, let's write that out. Okay, so be careful again not to assume things. Don't get your arrows mixed up with your equal sides. Okay, so in triangle BCE and triangle GDF, we've got CE equal to DF, and that's given. And we can say that angle ACF is equal to angle GDF, corresponding angles. Which parallel lines are we using? We're using AC parallel to DG. And then we can also say that angle BEC is equal to angle GFD, also corresponding. And that's because BE is parallel to AF. And then we've got triangle BCE congruent to triangle GDF, and that's for angle side. Okay, and now that we have these two congruent triangles, I'm just going to take some stuff away that we don't need here. We can say that this side is equal to this one because of the congruency. So our last question is for BEF. We have to prove that BEF is a parallelogram. BEFG is a parallelogram. So this one here, BEFG. So how would we do that? We would need, we've got a parallel side, 2 pairs of parallel sides we've got, and we just need them to either be equal, or we can prove the other pair of parallel sides. Yep, we can try and do both, or we can do one pair of parallel sides, one pair of opposite sides parallel and equal. Okay, what do you guys think? Okay, ma'am, what about B equaling to the top of the X in the middle? Is that fine too? B equaling to the top of the X in the middle. Can Vuchilo maybe try and give a angle reference, like using 3 points? Because I'm not sure which angle you're referring to. About B equaling the top. Do you know, Miss Nelly?
I think he meant just look at I think CBA, the B,
Yeah.
and the top part from D, between D and G, but the top part.
So CBE.
Yeah. It's like alternate lines between the parallel lines CB and DG.
Sorry, I don't know which angle it is. Can you give me an angle reference?
Yeah, where you have the pink dot for B.
Yeah.
And then like alternate lines between CB and DG.
Oh, this one.
Yeah.
Oh, there's no vertex there. So if the vertex is a name, try not to use it because it's probably not coming into play. Yeah, that is true. It is equal,
Right.
but it's not going to help prove anything. So yeah, it's not really useful. Okay, so what we need to do now is BEFG No problem. That's fine. I just couldn't figure out what angle you were referring to. Okay, Miss Nelly, let's prove this parallelogram. Anyone got any ideas? Pop it in the chat. BE is parallel to FG, opposite sides of a palm are equal. Now, BE is parallel to FG because it's given. So we either need to prove BE equal to GF, or we need to prove, oh, and it is, by the way, because of the congruency. So we can say BE, and I'm just going to do it here, BE is equal to GF because of the triangles being congruent. Triangle BCE congruent to triangle GDF. And BE is parallel to GF, that's given. And therefore BEFG is a palm. One pair of opposite sides parallel and equal. Okay, so Vichilo says angle B is equal to angle F, opposite sides of a palm, opposite angles of a palm. Okay, but we haven't proven it to be a parallelogram yet. So until you've proven it, you cannot say that it's a parallelogram. And remember, there are those 5 ways. You can go back on your notes and look, 5 ways to prove a parallelogram. And this is one of the ways, that one pair of opposite sides are parallel and equal.